Good morning, everyone. Today we're looking at Unit 5, Lesson 4, Combining Transformations of Sinusoidal Functions. So the past two lessons, we've covered all the different transformations you're going to in this course, and so today we're just going to put all those together. So some things to remember. Sinusoidal transformations work the same way as quadratic transformations. The x values are represented by the angle theta with sinusoidal functions. So the transformations that we have learned so far are our vertical stretch or compression. So that is affected by our a value. So our a value, if it's greater than 1, it's going to have a vertical stretch. If it's less than 1 but more than 0, so if it's a fraction, it's going to have a compression. And if it's a negative number, it's going to be reflected. Either way, because it's representing a vertical stretch, what that means is whatever that a value is, we're going to be multiplying it by our y values to stretch out the graph. Okay, the next one is a horizontal compression. So a horizontal compression is represented by our k value. Okay, and if this has kind of the opposite effect. So the bigger the number, the more it's compressed. So we divide our x values by our k. And if k is a negative number, it's going to be a horizontal reflection. So we take our x values, and because it's being compressed by whatever our k value is, we take all of our x values, or our thetas, and we divide them by k. All right, another one we learned was our horizontal or phase shift or translation. And that means if it's horizontal, we're moving it left to right. And so there it's going to affect, again, our thetas or our x values. So for this, it's a theta plus or minus whatever d is, because that's going to move it to the left or to the right. And remember that for a horizontal translation, it's going to be the opposite sign. So if we have minus a number, we're going to move it to the right. And if we have plus number, we're going to move it to the left. And then finally, we have the vertical shift or vertical translation. And because it's vertical, it affects my y values. So for this one, this is going to be y plus or minus c. Okay, and it's not the opposite sign. So whatever c is, that's either going to be added to c or added to y or subtracted from y. So these transformations also tell us about some of the properties of the function. So our trig properties are represented by some of those variables. So our amplitude is our a, and remember that's the vertical distance from our axis up to our maximum or minimum. Our period, which is the length it takes to complete one cycle, is going to be represented by taking 360 degrees and dividing it by k, because 360 is our standard period for our base function. And if we need to find our k value, if we need to work the other way, then we would just do 360 divided by our period. Our vertical shift is also going to represent our equation of our axis, so that's why y equals c. And then finally, if we're trying to figure out how often we're going to have a key point, we're going to take our period and divide it by 4. So we're going to go through some examples, and I'll try one, and then I'll get you guys to try one when you pause the video. So the first way we're going to graph these transform functions is we're just going to identify what the transformations are and then try to put that on the graph. So steps to sketch the transformations. We got to determine our theta values. So our theta values are affected by a horizontal compression or a stretch, and we're going to divide by that k value like we said above. So it's going to be our thetas divided by k value, and it must be in factored form. We'll look at what I mean by that in a minute. And then our thetas will also be affected by our horizontal phase shift plus or minus that d value. And then our y values will be affected. It'll be a vertical stretch where we'll multiply by our a value. So it's our y times our a value. And then if there's a vertical reflection, if a is negative. And then finally, a vertical shift up or down by c. So let's look at some examples here. So if we have y equals a -2 sine times 3, and then in brackets, theta minus 30, minus 1. We're going to describe the transformations. But before we do that, let's just graph our base function of sine. We should know what that looks like by now. So sine starts at 0, up to 1, back down to 0 at 180, down to -1 at 270, and then back to 0 at 360. So that's y equals the sine of theta. Okay, so if we were to go through and we were just to identify all of our transformations, we know that this 2 represents our a, the 3 is our k, the 30 degrees represents our d value, which we'll talk about what all of those mean in a minute. And then finally the 1 represents our c value. So we're just going to describe our transformation so that we can transform our base function of sine. So first, our a value is a -2. So what does that really mean? That means if it's negative, we're going to have a reflection in the x-axis, and we're going to vertically stretch the graph. So vertical stretch by a factor of 2. Okay, so that's what our a value is going to do. What's our k value is going to do? So k equals 3. This means we're going to have a horizontal compression by a factor of 3. Okay, our k value also helps dictate our period. So our period, if we were just going to put that over here, to find our period, we're going to take 360 and divide by that k value. So our period will be 120 degrees. If we wanted to find how often those key points would be, we're going to take our 120 and we're going to divide that by 4 because we know we have key points. We have 4 key points we need to hit. So we got to divide that period up into 4 sections. So we're going to have a key point every 30 degrees. All right, so that's that transformation. Our d value, which represents our phase shift, is a -30 degrees. So that means we're going to have a horizontal or phase shift is what it's called. And that's going to be right in the direction right, 30 degrees. And then finally, our last one is our c value, which is a -1. That represents a vertical shift up or down. So because it's a -1, that means we're going to go down. All right, now that we have all this information, we're going to try to put it all together onto a graph. So each point we're going to look at how does each of these variable values affect that point. So we know that we need to compress this vertically and that we're also going to stretch it. We're going to compress it horizontally rather, and we're going to stretch it vertically. So if we start at our first point, 0, we know that 0 has to be stretched, reflected, and then moved left or right, and then up or down. So we're going to do that to all of it. So first, we're going to look at this, it's at 0, and we need to stretch that vertically by 2. Okay, well, if I stretch 0 by 2, it stays at 0. It doesn't do anything. Same with if I'm trying to reflect that over the x-axis, right? If I try to reflect this point over the x-axis, well, it doesn't go anywhere because it's right on the x-axis. Then we have a horizontal compression, which means we're going to condense it by 3, so still not going anywhere. And then it says we have a phase shift. We're going to move it 30 degrees to the right. So I can move that 30 degrees to the right, which would be there. And then we're going to move it down 1. So pay attention to your scale. So that point's going to go there. And then we'll move on to the next point and continue. Okay, so this point, which is at 90 and 1, well, I know my next key point is coming every 30 degrees. So I need to go 30 degrees from my last point. So I'm going to be somewhere around this 60 here. Okay, so from that 60, my maximum is usually 1, but I have to stretch that by a factor of 2. So that tells me I have to go up to 2, but I also know that has to be reflected over the x-axis. So that means I'm going to reflect that point all the way over the x-axis, which may bring me down to -2. And then finally, I'm going to move that down 1. I'm going to move that down 1 to -3. All right? So we'll do the next point, and then we'll pause the video and we'll get you guys to try some of these points as well. So our next point is at 180. Well, the we can take out the phase shift because we know our key points are coming every 30 degrees. So after my 60, my next key point has to come at 90 because my key points are coming every 30 degrees. All right, so we're at 90. That's our horizontal compression. Then we need to think about our vertical stretch. Well, it was at 0, so there's nothing to stretch there because 0 stretched is just 0. And then we reflect that over the x-axis, and again, doesn't go anywhere because it's right on the x-axis. But we do need to move it down 1. So we're going to move it down 1 to -1. Okay, let's try a few more. So our next point, which was at 270 and 1, so or -1, we need to take that point and we need to move it according to our transformation. So our next key point for our transform functions, we were at 90, now we're going to be at 120 because we're moving 30 degrees. Then from there, we need to stretch it vertically. So if I was at -1, I'm going to stretch that to -2, but then reflect it over my x-axis. Right? And then finally, I'm going to move it down 1. So I end up being +1 there. And then my last point, as you can imagine, 30 degrees further to the right, and that's where my axis is. It should fall back on my axis. So if I connect all these points, starting with that first point, which was around 30 degrees, coming back up, you should have something like that. And you can see, especially because we know the pattern for sine, that our axis is where that C value was. Our C was at -1. Okay, our amplitude, if we go from our axis at -1 down to our minimum at -3, our amplitude is 2, which is what our A value represents. So all those transformations you can see happening here. So let's just label that. Y equals -2 sine 3, and then in brackets, theta minus 30 minus 1. All right, let's try one more. Get it set up and have you guys give it a try. Okay, so the next one, we are given a function again. We're going to describe the transformations applied to y equals the cos of theta. So this is, when it said it has to be in factored form, it's talking about this here. We can't have anything attached to our theta. We need to factor that out. So if I factor that out, we're going to have y equals the cos, and I'm going to factor out that 2 just in front and create a new set of brackets. So we'll have theta minus, and then remember, if we're taking a 2 out, we got to take the 2 out of the 122. So it'll become 60 degrees plus 2. All right, so go ahead and list your transformations and see if you can graph it on the graph. Graph your base function of cosine first in order to help you with the transformations, and then see if you can identify all those things in C. So state the period, the amplitude, the equation of the axis, and how often your key points occur. Okay, so there's what your transformed function should look like. So if we identify all of our transformations, and then we go through each point to apply that transformation. So my base function of y equals cosine of theta, let's go through these points and see if we can identify how we transform that point. So my first point here is at 0, 0, and 1, okay? So to transform that point, it needs to be horizontally compressed. But remember, it's at 0, so there's nothing to compress there. And then it's going to move to the right 60 degrees. So I'm going to move that to the right 60 and then up 2. So that's where that point goes. Our next point on our base curve was at 90 degrees. So I need to compress that by 2. So that's going to bring it back to 45 degrees. But then it gets shifted to the right 60 degrees. So I'm at 45. And then if I come back to the right 60, I'm going to be like at 105. So somewhere between my 90 and my 120. And then it gets translated up 2. So that's where that point goes. Okay, the next point we have is at 180 and -1. So if I was to horizontally compress that, that's going to go to 90 because 180 divided by 2 is 90. But then it's got to go back to the right 60 degrees. So I'm at 90 and I go to 60 degrees, bring me back here to 150, and then again up 2 to that point. So that's how we're doing that with each point. So my next point's at 270. 270 compressed would bring me back to 135, but then I'd have to move that back to the right 60. So that would bring me to 195, which would be right about there, and then we'd have to go up 2 from there. okay? So finally, if I took my point that's at 360, I compress that by 2, that'd bring me to 180, and then I have to shift that to the right 240, so my point would be somewhere there, and then again, up 2. Okay, and then I would just repeat the pattern of going from max to axis to minimum to graph 2 cycles. Okay, let's identify some of those key periods. So our period, our key properties, our period is going to be 360 divided by our k value. All right, and our k value in this case is 2. So our period is 180 degrees. And if we wanted to check that, if we wanted to see what our period is, well, the cycle starts at 60 and it ends at 240. So 60 to 240, that's 180 degrees. That's our period. Okay, so you could see that by looking at the graph. The equation of our axis, you can see I already drew that dotted axis line that goes right through the middle. And our axis is also represented by our c value, which in this case is 2. So we'd say the equation of our axis is y equals 2. I skipped over, I didn't mean to, our amplitude. Our amplitude is just our a value from our equation. And you can see I highlighted up here. We didn't have a coefficient, so I just wrote in a 1 because that's what's implied when we don't have a coefficient. So that is our a value. So that means that's also going to be our amplitude. And then how often do the key points occur? Remember, the key points are going to occur, we need 4 of them. So we're going to take our period and we're going to divide it by 4, which equals 45 degrees. So key points occur every 45 degrees. All right. I'm going to pause it again, and I'm going to let you guys give this one a try. Remember that you have to first factor out that 0.5 in front of your theta. Okay, so I've listed our transformations from our equation, making sure that I first factored out that 0.5. Remember, when we factor out that 0.5, we factor it out from both of the terms inside of our bracket. So we're factoring it out from the theta, but we're also factoring it out from the 45. Okay, and then I graphed my base function for sine, because we already know what that looks like. And now we're going to apply those transformations to each point on the graph. So my first point here at 0, 0, I need to vertically stretch that by 3. So it's at 0, so that doesn't change it. And then it needs to be horizontally compressed. Again, not going to change it because we're at 0, but it does need to shift to the right 90 degrees as well. So that's where that point's going to go. My next point is at 90 and 1. So I need to vertically stretch that by 3. So if I multiply that by 3, that's going to bring me up to 3. But it also needs to be horizontally compressed by a factor 0.5, which means it's going to double in size. Because if we divide something by 0.5, it's going to get bigger. So that point that was at 90 is now going to go to 180, somewhere here. And then we have to then shift that 90 degrees to the right. So that point will go there. So you can see how our graph is getting larger. Our next point, which is at 0, 180. Okay, if I stretch my 0, that doesn't change anything. But I need to compress it. Which remember, if I'm compressing by a decimal or by a fraction, it's going to get bigger. So that's 180 divided by 0.5 is actually going to go to 360. And then I need to move that point 360 to the right 90 degrees. So that will get you up to 450. All right, so that's the next key point. My third key point, well, was at 270 and -1. So I need to take that point, stretch it vertically by 3, which brings me down to a -3 somewhere in here. But I need to compress that by 0.5. So if I'm at 270, well, that's going to double it. So 270 doubled is going to move me over to 540. And then I need to move that to the right 90 degrees. So 540 and then right 90 is going to put me right there at 630. Okay, and if I want to do my last point, it's going to be a little bit off the chart here, but that's okay. We can take my point at 360. Doesn't need to vertically stretch because it's at 0, so it won't change. But if I horizontally compress it by 0.5, that's going to shift me all the way over to 720, which would be about here. And then I got to move another 90 to the right. So it would be off the graph a little bit. So if I wanted to connect my points to make a smooth curve, right, we can see that the graph got stretched vertically and it also got stretched out horizontally as well. Okay, and if we wanted to follow that pattern, if we were trying to create two cycles, we can just follow that pattern. So I know from this point here at 90 and 0, my next point, if I was moving in a leftward direction, would have to go down to my minimum, which is -3. And it looks like each key point, if I count here, so from one key point to the other, how far away is that? Well, it's from 90 to 270, so 180 degrees. So I'd have to go back 180 degrees to the left to plot another key point, so it'd be around a -90, and my minimum would be at, -3. Then from there, it goes up to my axis. So I know I'm going to have to go back up to my axis, but again, I'm going to have to go another 180 degrees, which would put me at a 270 and back up to my axis. Okay, so we could extend the graph this way. All right, and then so on off the length of the graph. Let's identify some of those key features. So our period, we can see our period is clearly longer now. Okay, we're going to take our K value to find our period. So our K value is 0.5. So 360 divided by 0.5 is 720 degrees. Our amplitude is just whatever the A value is from our equation, and our A value in this case is 3. The equation of our axis comes from the C value of our equation, so y equals 0. And finally, our key points are so if we want to figure that, we're going to take our period and divide by 4, which is 180. So our key points are every 180 degrees. Okay, we were going to identify our domain and range. For these sinusoidal functions, our domain remains unchanged. It's always going to be x for all real numbers. But remember, for our range, our y values are affected by those maximum and minimum values. So my minimum value is a -3, and my maximum value is a +3. So our range would be between a -3 and a +3. Okay. Now we're going to look at how do we graph these functions using a mapping tool. So instead of trying to go point by point to see and apply transformations, we're going to try using this mapping tool to first recognize what our points are and then plot them on the graph. Okay, so we'll try one together and I'll get you guys to try one. So we're going to use the transformations on A, K, D, and C to create a table of values. And this is how those values affect the function. So if we have y equals A times sine, and then in brackets K, another brackets theta minus D plus C, and then even if we did that on the cosine function, we already talked about how do those variables affect either my theta or my y value. Okay, so think of our base function as all of our coordinates have a theta and a y. When we apply transformations to them, we're doing certain things to our thetas and to our y. So on our thetas, the k and the d affect it. So whatever our k value is, we're going to divide our theta by that and then add d. All right, on our y values, we're going to multiply by a and then add c. All right, so let's identify all those values in this function and see if we can fill out our table of values. So if we have y equals 2 sine and then theta plus 90 minus 1, we can identify, just like we did using the other method, what these variables are. So our k value is just 1 because there's nothing there. And then our d is a plus 90. And finally, our c is a minus 1. So we'll just write that information in here. So we have a plus 90 and we have a minus 1. Okay, and then our table of values, we're always going to set up our base function. So this is y equals the sine of theta. when we use those theta values. So let's graph those first on our graph below here. So our sine function, as we know by now, starts at our axis, up to our max, back to our axis, and then down to our minimum, and back to our axis. So that's what our base function of the sine curve looks like. Now we're going to apply all these transformations, but we're going to do it in table of values and then put it on the graph. So we're going to start with all of our theta values. Our thetas are affected by that k. So we're going to take theta divided by k plus d. So if my theta is 0, I'm going to do 0 divided by my k value, which is 1, plus my d value, which is 90. So you have to remember here that this is the opposite of what's happening, right? We always use the opposite sign for what's going on in my d. So this would be minus 90. So 0 divided by 1 is 0, minus 90 would be a negative 90. So let's just write our general rule up here. So for this whole table of values, we're going to do theta divided by 1 minus 90. Okay, so we'll move to the next one. So 90 divided by 1 is 90, minus 90 is 0. 180 divided by 1, 180 minus 90 is 90, okay, and so on. If we were going to go ahead and do our y values next, we can plug in the variables we know here for our y value. So our y value, or our a value rather, is 2, so we're going to do 2 times y, and then we're going to put the c value on there, okay? So that is just the same sign that's there, so that's going to be minus 1. Okay, so we'll apply that to all of our y values. So our first y value is 0. So if we were to say 2 times 0 minus 1, well, that equals negative 1. Okay, our next one, if we were to do 2 times 1 minus 1, that's going to be 1. Okay, and you could carry on those operations, and those are the values you should get. Now that we have that information, we can just create a coordinate to plot on our graph. So all of these would become the coordinates that we plot to see our new transformed function. And then finally 270 and negative 1. So I'm going to plot those points on the graph. So we have one at negative 90 and negative 1. And then we have 0 and positive 1. We have 90 and negative 1. You can see that's probably our axis we're going back to. We have 180 and negative 3. And then we have 270 and negative 1. Okay, so if I connect those, we have one cycle. But if we wanted to repeat our pattern, we could follow the pattern that's happening here. So I would just say follow pattern to plot additional cycles. Okay, so if I was following this pattern, it looks like between my x values, so I went from 180 to 270. So each point is going to go another 90 to the right. So I'm going to go back up to my maximum here. I'm going to have to go over 90, so that's going to put me at 360. And my maximum was at 1. And if I go another 90 to the right, that would be 450, and it brings me back down to my axis. And then another 90 to the right would be 540, down to my minimum. And then finally another 90 to the right would put me at 630, and back to my axis. So I just follow that pattern that was created in the one cycle in order to plot additional cycles. So here we have y equals 2 sine theta plus 90 minus 1. Okay, let's try one more. So I'm going to pause the video here. Actually, before I pause it, let's just make sure we factor it out correctly. Because remember, you need to have whatever's in the bracket be factored out. So if we're to factor that out, we're going to have negative 2 cos, and we're going to factor out a 1/2 so that we don't have a coefficient on theta. But when we factor 1/2 out of 45, that's going to become 90. Remember, we do 45 divided by 1/2. Okay, so pause the video, see if you can identify the trig properties, fill out your table of values, and graph 2 cycles. Okay, so there's the transform function of the cosine function given above. You'll notice that this one was reflected, so it should look flipped compared to the other one. If we wanted to extend this for 2 cycles, we would just follow the pattern where we can see that we have a key point. So if I was to identify how often are key points, so from here to here, okay, what's the distance between key points? So we went from 90 to 270. So there's 180 degrees between each point. So if I wanted to work backwards, I'm at 90 now, I'd go 180 back, and then I need to go back up to my axis here, which is at 1. So that'd be a negative 90. Then from here, I'd have to go another 180, so I'd be at a negative 270, and we're going up to our maximum, which our maximum here is at 3. Okay, and then if we wanted to really complete 2 cycles, we'd have to go another 180, and then down to our axis, which would be somewhere over here. Our axis is at 1, so we could round that and come back over here. Make that a bit more rounded. All right, so that's what that graph looks like transformed. Make sure you guys practice this both by able to identify the transformations and by using that mapping tool. That's it for today.